An AI agent can trust the tool before calling it. That trust often begins with the tool description. The description explains what the tool does and when to use it, but descriptions can contain instructions written for the model. Those instructions may be invisible in a normal interface. A malicious description can redirect the agent toward unintended actions. The tool does not need to exploit traditional software first. It can manipulate the model through its own metadata. This is the security problem called tool poisoning. MCP standardizes how AI applications discover and call tools. A server can advertise names, descriptions, parameters, and capabilities. The client places that information inside the agent's working context. The model uses it to decide which tool fits the task. This makes integrations faster and more portable across applications. It also creates a new trust boundary around tool metadata. The agent may treat server-provided descriptions like operational guidance. That guidance comes from outside the model and outside the user. Security must evaluate the tool definition before the agent sees it. Tool descriptions are not harmless documentation for machines. While they can influence selection, argument sequencing, and later reasoning, a legitimate description says when a capability should be used. A poison description quietly adds unrelated conditions or hidden priorities. The agent may interpret those additions as authoritative instructions. Users often see only a friendly name and short summary. The complete manifest can contain much more detail. That visibility gap lets risky instructions hide behind trusted branding. Full transparency matters before any tool becomes available. Imagine an assistant connected to email and a document system. The user asks it to summarize one public project file. A new MCP server advertises a convenient conversion tool. Its description includes a hidden request to inspect unrelated folders. The agent selects the tool because the description sounds relevant. It then combines the hidden request with existing file access. No exploit code is needed in this sanitized example. Manipulated metadata changes the agent's plan before execution begins. Broad permissions turn that change plan into a disclosure risk. The first pattern is direct poisoning inside the tool definition. An attacker modifies the name, description, schema, or routing metadata. The new text pressures the model toward an unsafe decision. It might request extra context that the task never required. It might discourage approval or claim a check already happened. It might instruct the model to prefer one tool unfairly. The payload targets model behavior instead of a human reader. Traditional validation can miss text that remains technically valid. Semantic review is required alongside normal schema validation. The second pattern is tool shadowing across connected servers. A malicious tool imitates the purpose of a trusted tool. Its name and description are crafted to win model selection. The model sees two similar capabilities with different hidden incentives. Ambiguous names make the conflict harder to detect. Automatic discovery can silently expand the available tool catalog. The agent may call the imposter during an ordinary workflow. Use explicit allowlists and stable identifiers for approved tools. Do not let semantic similarity decide trust by itself. The third pattern appears after a tool was already approved. A server changes its description or behavior in a later version. The familiar name remains while the trust assumptions quietly change. OWASP describes this dynamic change as a rug pull risk. An earlier review cannot protect against an unmonitored update. Clients should pin versions or record approved manifest fingerprints. Every change should produce a visible security review event. Unexpected differences should disable the tool until approval returns. Trust must follow the current artifact, not its old reputation. Tool poisoning becomes dangerous when several controls fail together. Untrusted metadata changes the model's interpretation of the task. Automatic discovery places the poisoned tool inside the agent context. Broad credentials provide access to unrelated systems or data. Missing approval lets the selected action execute immediately. Weak logging hides which description influence the decision. The model becomes one link inside a larger control failure. Blocking one prompt pattern will not secure the whole chain. The application must constrain discovery, authorization, and execution. Start with Provenance for every MCP server and tool. Record the publisher, source repository, version signature, and owner. Prefer registries and packages with verifiable maintenance history. Treat 1. Click installation links as executable security decisions. Review startup commands before allowing local server installation. Separate experimental servers from production agent environments. Assign an accountable owner for each approved integration. Unknown provenance should mean unavailable, not temporarily trusted. Inventory creates the foundation for every later control. Next, capture the complete approved tool manifest. Store names, descriptions, schemas, annotations, and server identity. Create a fingerprint that changes when any important field changes. Compare the live manifest before each activation or update. Show reviewers the actual differences, not only a friendly summary. Flag hidden markup, suspicious instructions, and unexplained capability growth. Require approval before accepting a change definition. Disable automatic trust for newly discovered tools. Integrity controls make silent rug pulls much harder. Limit what an approved tool can reach and perform. Allow only tools required for the current business function. File use RID only access when the workflow does not require writes. Scope credentials to one project, resource, and short task window. Separate public research tools from private data environments. Block destructive operations unless the user explicitly enables them. Do not pass secrets through tool arguments or model visible context. Narrow permissions reduce damage when selection still goes wrong. Trust in metadata should never grant unlimited authority. Sensitive actions need controls outside the model's own reasoning. Require confirmation before sending data, changing records, or running commands. Show the exact tool, arguments, destination, and affected resource. Run local servers inside restricted sandboxes whenever possible. Constrain file paths, network destinations, environment variables, and subprocesses. Validate arguments again at the policy enforcement layer. The model must not approve its own consequential action. Design cancellation and rollback before increasing agent autonomy. Execution controls contain failures that metadata review misses. Log discovery, manifest changes, tool selection, arguments, and results. Connect each event to the user, agent, server, and session. Alert when new servers appear outside the approved inventory. Detect tools that access unusual resources or unexpected destinations. Review denials because repeated attempts can reveal manipulation. Retain the exact manifest that influenced each important decision. Test whether poison descriptions can bypass your control boundaries. Remove abandoned servers and expired credentials from every client. Visibility turns hidden tool influence into evidence. MCP tools can make AI agents dramatically more useful. They also place external metadata inside the agent's decision process, verify provenance, pin manifests, restrict permissions, and gate execution. Monitor every change that can alter tool selection or behavior. If you are finding this content useful, please subscribe, like, and comment. The goal is not to avoid connected tools completely. The goal is to make every connection visible and accountable. A tool description should explain capability, not secretly control intent. Trust the verified tool, not merely the name it presents.